In question 4a, the curve with the equation y equals to x squared plus 2x minus 5 is translated by minus 1 and 3. We have to find the equation of the translated curve, giving our answer in the form y equals to ax squared plus bx plus c. Now, when we have a translation in the x and the y direction, so let's say if you have a function y equals to f of x, if there's a translation in the x direction and the movement is of a units, so we write it as y will be equals to f of x minus a. And if there is a translation of a units, or let's say in this case b units in the y direction, it means we'll add b to the complete function f of x. So in this case, y will be equals to f of x plus a. So as we have both the translation in the x and the y direction, so this will be y equals to, in place of x we will write x, x minus 1, so this will become x minus 1, so this will become x plus 1 whole squared plus 2 into x plus 1. This was a minus 5, and as is a translation of plus 3, so we'll write a plus 3 up here. Now expanding the expression, we'll get x squared plus 2x plus 1 plus 2x plus 2 minus 5 plus 3. Simplifying this, we'll get y equals to, so x squared will remain as it is. 2x plus 2x will make it a 4x. 1 minus 5 is minus 4, minus 4 plus, so this is 1 plus 2, 3. 3 minus 5 is minus 2, and minus 2 plus 3 will make it a plus 1. So the equation will be y equals to x squared plus 4x plus 1. In part B, it says the curve with the equation y equals to, so the original equation is x squared plus 2x minus 5. Now it is transformed into y equals to 4x squared plus 4x minus 5. We have to describe fully the single transformation that has been applied. Now, as we are talking about a single transformation, it means that there is no stretch in the y direction, because if it was in the y direction, then we would have multiplied the complete function by the stretch factor for y. So as only we can see that the values of x has doubled, so we can say that it will be a stretch factor. So as only the values of x have doubled, we'll say that the stretch factor will be in x direction, and the scale factor will be equals to 1 upon 2. Now for stretch in the x direction, if we have a function f of x and there is a stretch, so if there's a stretch in the x direction of scale factor, let's say a, in the x direction, so that function basically, we divide the x values by a. So if there's a stretch factor of 1 upon a, then in that case, we multiply the value of x by a. So if we take the stretch factor as 1 upon 2, so for the original equation, y equals to x squared plus 2x minus 5. In place of x, we'll write it 2x. In place of x again, we'll write it 2x minus 5. So this will be equals to 4x squared plus 4x minus 5. So basically, this represents a single transformation, which is a stretch factor in the x direction, and the scale factor will be 1 upon 2.